Let's practice some parallel and perpendicular lines. Number 1 and 2 are determine which of the lines, if any, are parallel and explain. All right, so we need the slopes, okay? And how you find slope is y2 minus y1 over x2 minus x1. And I could set these up in that format, but really I just kind of like to do it, not even technically mentally. Here's what I do. If I were doing this in front of you, I'd put my finger right here, I'd put my other finger right here, and then I would just go, okay, 5 minus 4, right? Or I'd do it like that. I did that on the last video just to kind of communicate what was happening. So 5 minus 4 over 1 minus negative 1. And I am writing it out like this right now, but on the next few I will not. 5 minus 4 is 1. 1 minus negative 1 is 2. That's the slope of this first one. So here I'm going to write that out next to it, 1/2. This one passes through. We got 4 and 7. That's negative 3. 0 minus negative 2. That's positive 2. So this guy is negative 3 over 2. Okay, and then the next one, 5 minus 4 is 1, and 2 minus 0 is 1/2. So I'm going to go ahead and say that these two are parallel to each other. Number 2. So these, we're not given points, so what I would do is I would put them in slope-intercept form, because in that form, I just look at the thing in front of x, and boom, that is the slope. So on line A, I could just divide everything by 6, and I would get y equals negative 1/6 x plus 2. Let's see. For this one, I could subtract 5 and get x minus 5, and then divide by 6. So I'll get y equals positive 1/6 x minus 5/6. And this last one, I could subtract x and then divide by negative 6. So I would get y equals positive 1/6 x minus 5/6. And so we're looking for the same slope. That's what you're looking for when it comes to parallel. So unfortunately for this guy, he does not have the same slope as these, because his slope is negative 1/6. These guys have the same slope, but there's something funky about them. They are the exact same line. So our answer for this one is no, none of them are parallel. None parallel. By the way, the symbol for parallel is just 2 parallel lines, just like that. None parallel. And then part of the reason that none of them are parallel is line B and line C are the same. And if you're the same line, how could you be parallel to yourself? Also, I didn't write over here my explanation. My explanation was those two have the same slope. So that's why they're parallel. Number 3 and 4, write an equation of the line that passes through the given point and is parallel to the given line. So you're going to see me give some multiple answers here, because all it says is write an equation. It doesn't say it has to be slope-intercept form, so that it could be this form. It could be this form. It could be this form. But we just took a quiz where you were allowed to do this form, or this form, and not a single one of you chose that form. And that makes perfect sense. But anyway, if I'm going to write an equation of a line that's parallel, then I need to find the slope of this line. And how I'm going to do that is get y by itself. So 2y equals x plus 8, divide by 2 to get 1/2 x plus 4. So here's my slope that I'm going to be working with, and that's my point I'm going to be working with. So I'm going to do point slope form to start with. So y minus y equals the slope that we just had here, and it's going to be the same slope, so that's why I'm using it, and that is times x minus 14. So technically speaking, that's an answer right there. You could stop right there. But maybe you went ahead and simplified it to slope-intercept form. So that's fine. Let's do that. So y minus 3 equals 1/2 x minus 7. you're going to add 3 to get y equals 1/2 x minus 4. That's an answer. That's an answer. Same thing on this one. It's just going to be a little bit faster because I don't need to do 2 moves. I just need to divide by 3, and I get y equals 2/3 x minus 1/3. This is the slope that I'm going to be needing. So y minus -5 equals 2/3 x minus 3. This is one acceptable answer. If you want to simplify it, that's fine, because it would be y plus 5 equals 2/3 x minus 3. That's fine. But we're going to now solve it for y, just so that if you did the other version of it, like if you did the slope-intercept form, then you'd get it. So I distributed 2/3, and I got 2/3 x minus 2, because 2/3 times -3. The 3's are going to kind of cancel out and give us -2. And then now I need to subtract 5, so it's y equals 2/3 x minus 7. So that's one answer. There's the other answer. Now we're determining if they're parallel or perpendicular. So we need the slope. I mean, they all come down to slopes is their biggest thing. So -1 minus 2, that's, well, hold up, -1 minus -2, almost made a mistake. That's -1 plus 2, or 1. And then 1 minus -5, so that's 1 plus 5, that's 6. Sorry, this slope is 1/6. Let's change colors here. 6 minus 5 is 1. 3 minus -3 is 6. That's this one. And last is 1 minus 7, that's -6. 1 minus 0, that's 1, or just -6. So check this out. We have a combination of answers here. We have A and B. They are parallel. So there's the symbol for parallel. And then let's see. C is perpendicular to A, and C is perpendicular to B. So hey, we learned another symbol here. This is perpendicular. And we technically need to explain why. So here's our explanation. For these two, it's because C's slope is a negative reciprocal to A and B's slope. And then for the other one, for A and B, they have the same slope, same slopes. So those are our explanations for those. Slide over here. Just like the previous one, we just need to get the slope. And just like the previous one, it would be helpful to get this in slope-intercept form. So we have 2y equals x plus 3, divide by 2 to get 1/2 x plus 3/2. I'm going to add 1, because that's kind of the fastest way to get y kind of on its side by itself. And then divide by 3, so we get, I don't know why I changed colors. So we get y equals -2x plus 1/3. And the last one, I'm going to subtract 4x. Let's zoom in here. And divide by -8. All right, so this one has a slope of 1/2. This one has a slope of 2. This one has a slope of 1/2. Just like this one, we have a combination of answers. So this one is A, B, and C. So A is parallel to C because they have the same slopes. And B is perpendicular to A, and B is perpendicular to C. And it's because B has a negative reciprocal slope to A and C. Okay. In 7 and 8, write an equation of a line that passes through the given point and is perpendicular. So again, we need the slope. Hey, look, there it is because it's in slope-intercept form. So there's our slope. The new slope is going to be positive 1/5. This is our new slope, okay? I'm going to put him in a fancy box because he's new. It's 1/5. So we're going to do the point slope form. Y minus y equals our slope times x minus our x. So this is an acceptable answer, but we could also continue to simplify. Y minus 1 equals 1/5 x plus 3/5. And we're going to add 1 to get 1/5 x plus 8/5. That's a good answer. That's a good answer. Number 8. They've been so nice to us that that's our slope. So our new slope is going to equal -1/2. Now, you'll notice, by the way, I haven't used my fun way of remembering this. I keep saying negative reciprocal because that's like the mathematical way of remembering it. But my fun way of remembering it is it's the super opposite slope. If that's 2, what is the opposite of 2? Well, -2 works. But then what's get me more opposite? Okay, well, flip it upside down. Yeah, so that's how it's -1/2. Okay, great. Y minus y equals the slope times x minus x. And so, like I said previously, that's a perfectly fine answer. But if you'd like to simplify, be my guest. And then we're going to subtract 5. This is also a perfectly acceptable answer. All right, we have a company laying new fiber optic cable underground. One cable will be perpendicular to the road shown, passing through the point 7-2. At what point will the cable pass through the road? So they tell us that this is a 1x1 grid. So that helps us to find the slope because we could just rise 1, 2, and run 1, 2, 3. So the slope of this line is -2/3. And if we want a perpendicular slope, it's going to be +3/2. And it needs to go through that point. So y minus 2 equals 3/2x minus 7. But really, it wants to know at what point will the cable pass through the road. So let's go ahead and graph this thing. It's going through 7-2, which is right here. And we know that the slope is 3/2. So down 3, back 2 would look like that. Down 3, back 2. And we're on a kind of a fortunate streak that they gave us this kind of exact point right here of 3, -4. So 3, -4. I guess I didn't technically need to get that answer, but there it is. Determine whether they are always, sometimes, or never true. A line with a positive slope and a line with a negative slope are perpendicular. Let's go with sometimes, because it could be, hey, here's -1/2, and then here's the new one, it's +2. Yeah, those are perpendicular, but what if I said that the other slope was 3? Well, then it wouldn't be perpendicular. So, yeah, sometimes. A vertical line and a horizontal line are perpendicular. Always, because vertical line has a slope that is undefined, which is something divided by 0, right? And a horizontal line is 0 divided by something that's 0. So, check it out. If you were to flip that upside down, well, then that would be 0 over something. And if you were to flip this upside down, it would be something over 0. And you might be thinking, well, what about positive and negative? You can't really have a positive or negative 0, right? So, always. 2 horizontal lines are perpendicular. That is never true, because I could draw that, a horizontal line, and I draw that one. And horizontal is perfectly 0 slope. So technically, they would sometimes be parallel, but never perpendicular. So that's it for the practice. Let me know what questions you got. See ya.